In this video, I am going to go over some of the questions on the study guide to help where there might be some questions. The first question I'm going to go over is number 8, and this is where it is asking you to list each element contained in this compound and how many atoms are in this compound. So when you look at this compound, we've got a coefficient in front of the whole compound, so we have to make sure we multiply all the subscripts by the coefficient. So the first thing I'm going to do is list all the atoms. So I have strontium, phosphorus, and oxygen. And so one thing we have to be really good at when balancing equations is counting the number of atoms in a compound. So in this situation, I have 3 strontium atoms in this whole compound. I have to multiply it by 2. So 3 times 2 gives me a total of 6, because I actually have 2 of these compounds when my equation is balanced. And then phosphorus is in parentheses, so there's an understood 1 there, and I multiply that 1 times 2, which gives me 2. Then I have to multiply it by the subscript of 2, which gives me a total of 4. And oxygen, I have the 4 times 2, then I have to multiply it by the subscript of 2. Oops. So 4 times 2 is 8, times 2 is 16. So I have 16 oxygen. Number 16 on the study guide is a worded equation, and the directions say to convert the following word equation to a formula equation and balance, and include the state labels like solids, liquids, and gases. So we have 2 solutions, sodium phosphate and calcium chloride, react and yield aqueous sodium chloride and a solid calcium phosphate. So the first compound I'm going to make is sodium phosphate. So this is where we have to look up the charges. So sodium is a +1. Phosphate is PO4 with a -3, and you use your reference sheet to look that up. So when I'm making this compound, I'm going to give the 3 to sodium and the 1 to phosphate. So I have Na3PO4. And it is a solution, so I'm going to put AQ. Plus calcium chloride. Calcium has a +2 charge. Chlorine has a -1. I give the 2 to chlorine, the 1 to calcium. So I have CaCl2. And then we put yield. And the state of matter for this is AQ. Then we have an aqueous sodium chloride. Sodium chloride is NaCl, and we put AQ. Plus solid calcium phosphate. So we have calcium, Ca +2, and then phosphate is PO4 -3. I'm going to give the 3 to calcium and the 2 to phosphate. So that is Ca3PO4 in parentheses with the 2 on the outside, and this is a solid. Okay, so that is the equation. Now, after we do this, we have to balance it. So I'm going to list my atoms. I have sodium, and then I have PO4, and I'm going to check on my product side to see if I have PO4, and I do. So I'm going to keep PO4 together. It's going to count them as a group. And then I have calcium and chlorine. This side, the arrow, I have the same thing. PO4, calcium, and chlorine. And then I'll count. I have 3 sodiums. I have 1 PO4, 1 calcium, and 2 chlorines. On my product side, I have 1 sodium, 1 chlorine, 2 phosphates, and 3 calcium. So nothing is in balance at all. So let me start with my sodium. I need 3 sodium on my product side, so I'm going to put a coefficient of 3 there. Recount everything. That gives me 3 sodium, and it gives me 3 chlorine. So my chlorines are still out of balance. That didn't even help my chlorines. I maybe should have started with calcium, so I think I might have changed something already. So my calcium, I have 3 over here, and I need 3 over here, so I'm going to put a 3 there. That does give me 3 calciums, and it gives me 6 chlorines. And then phosphate, I need 2 over here, so I'm going to put 2 there. That gives me 2 phosphates and 6 sodiums. So I will come back to this side and take away this 3 and put a 6. So that gives me 6 sodiums and 6 chlorines, 6236, 6236. So I probably should have started with calcium. But we had 2 metals, so sometimes you just start and you have to change as you go. But we got it. So our coefficients for the balanced equation is 2, 3, 6, and 1. This is number 19, and we are just asked to balance this equation. And I just balanced the equation on the last one. So this is another one showing you how to balance an equation. And once you learn how to balance, you basically have to balance every time you make an equation. All right, so first thing I'm going to do is list the atoms. I have calcium, and then I have OH. So I want to check. I have OH here. Do I have it on the product side? And I do. It did not break up. So I'm going to keep it together as a group. And then I have iron and chlorine. So on the product side, I'm going to have the same thing: calcium, OH, iron, and chlorine. So I start counting. I have 1 calcium, 2 OHs, 1 iron, and 3 chlorines. On the product side, I have 1 calcium, 2 chlorines, 3 OHs, and 1 Fe. All right, calcium is in balance. Our OHs are not. And then iron is, and chlorine is not. If I look at my OHs, I have a 2 and a 3. So that tells me I'm probably going to have 6 of both of those. That's my first guess. So I'm going to see about balancing those and see what happens. So in order to get 6 OHs, I need to put a 3 in front of calcium hydroxide. That gives me 3 calciums and 6 OHs. And then I come over on the other side, and I have to put a 2 in front of Fe. That gives me 2 irons and 6 OHs. All right, so my calcium is out of balance, and so is my chlorine. But we're just going to keep working. We're going to take one at a time. I'm going to go with the calcium. I need 3 on the product side, so I'm going to put a 3 there. That gives me 3 calcium, and it gives me 6 chlorines. So then I'm going to move to the iron. I have 1 on the reactant side and 2 on the product side. So I'm going to put a coefficient of 2 in front of iron chloride, iron 3 chloride. That gives me 2 iron and 6 chlorine, And at that point, I think we are balanced. We have 3, 3, 6, 6, 2, 2, and 6, and 6. Number 24. In this section, you're told to say what type of reaction is it and balance it. And some of the equations will have to predict the products. But the first one I'm going to do is a combustion equation. I know this is combustion because I have the carbon dioxide and water. And make sure it has both of these, not just water. Water appears a lot in a lot of reactions. So we have to have the carbon dioxide with the water. And actually, you should probably check for this oxygen right there. Okay, so in these equations, it's always carbon, hydrogen, and oxygen. Those are the only three elements present on both sides. And we were given some clues about how to balance this. The first one was to just put a coefficient of 1 there. Now, we don't actually write that coefficient. We just pretend that it's there. Okay, so we're going to count the atoms. I have six carbon and 6 hydrogen. I'm not going to worry about the oxygen yet. We are going to leave this until the end. All right, so to get 6 carbon over here, I have to put a 6 in front of the carbon dioxide. And then I count everything. So that gives me 6 carbon, and then it's going to give me 12 oxygen. So I'm just going to write that up there. In order to get 6 hydrogens on the product side, I need a 3 here. So 3 times 2 is 6. And then that gives me 3 oxygens. So we have 12 plus 3, which equals 15. That is an odd number. I need it to be an even number because I'm going to multiply it by 2. So 1, using the coefficient of 1, did not work. So we're going to erase all this. And then we're going to use a coefficient of 2. All right, so let's start over. This time we're going to put a 2. That gives me 12 carbons and 12 hydrogens. So I come over to the product side. I'm going to put a 12 here. That gives me 12 carbons and 24 oxygens. I put a 6 here. That gives me 12 hydrogens, and it gives me 6 oxygens. So 24 plus 6 equals 30. So we need a 15 in front of this O2 to give us 30 oxygen on each side. I think we did this one in class as well. This is number 31. So we're given half of the equation written in words, and then we have to figure the rest of the equation out. So this is aqueous calcium chloride. So we have calcium, which is plus 2, plus chlorine are coming together to make a that's a minus 1. We're going to crisscross, and our formula is CaCl2. Is mixed with sulfuric acid, which is H2SO4, the very common acid. If you don't know the formula, it might be one that you want to memorize. And that's all we're given. So at this point, we draw an arrow and we have to finish the equation. And this looks like it's going to be a double replacement reaction, so they're going to switch partners. Calcium and hydrogen are going to switch. So calcium is going to bond with sulfuric acid. So the calcium is plus 2, and sulfate is minus 2, so we just need one of each, CaSO4. And that means the hydrogen is going to bond with chlorine. So hydrogen is plus 1 and chlorine is minus 1, and that's HCl, which is actually hydrochloric acid. Okay, So double replacement, and we finished out the equation. And now we have to balance it. So once again, we're listing all the atoms on both sides. We have calcium, chlorine, hydrogen. I can keep SO4 together because it's on both sides. So calcium, chlorine, hydrogen, and sulfate. Okay, then I count. I have 1 calcium, 2 chlorines, 2 hydrogen, 1 SO4. Over here I have 1 calcium, 1 chlorine, 1 hydrogen, 1 SO4. So this looks pretty easy. There's my unbalanced, the hydrogen and chlorine. So it looks like if I put a 2 there, I'm going to change those to 2's and everything is balanced. Double replacement reaction. Calcium and hydrogen are switching places. You make your new formulas over here. You always have to go get the charges and make the new formulas. You are not taking these subscripts and just moving them over here. That's not how it works. You have to redo the formulas. Everything's getting shifted and rearranged. Okay, so the last problem I'm going to help you with is number 35. We have to complete this equation and then balance it. This is another double replacement reaction, and so we are going to have iron and sodium switching places. Now when this happens, I have to get the charges and rewrite the formulas. So I'll start with iron. Iron is going to bond with carbonate. So iron, and how do I know the charge of iron? Well, it's that number right there. And it's positive because it's written first and it's a metal. So iron is +3, and it's going to bond with this carbonate there, which is CO3 with a -2 charge. And I looked that up from my reference page. So then we're going to take these numbers and crisscross them. So I have Fe2 CO3 in parentheses with a 3 on the outside. The next compound that's formed is sodium is bonding with nitrate. So I don't take Na2, that's not going to work. I have to get sodium, which is a +1. It's going to bond with nitrate, which is NO3 with a -1. So that's going to be NaNO3. Now I balance the equation. So we have iron, nitrate, it's on both sides, sodium, and carbonate. On the other side, we have iron, nitrate, sodium, carbonate. All right, 1 iron, 3 NO3s, 2 and 1. Over here I have 2 irons, so I can see that's out of balance. I have 1 NO3, 1 sodium, and 3. So it doesn't look like anything is in balance. Let me try to clean this up a little bit. Okay. What do we want to start with? We could start with iron or sodium. All right, let's start with iron. So if I put a 2 here, that gives me 2 iron, and it gives me 6 of NO3s. So if I look at sodium, I'm going to wait on sodium because if I need 6 NO3s over here, the only way I can get a 6 is to put a 6 here. So that gives me 6 sodiums, and it gives me 6 NO3s. In order to get 6 sodiums on the reactant side, I need to put a 3 here. That gives me 6 sodiums and 3 carbonates, and then that in turn balanced my last one. So our coefficients are 2, 3, 1, and 6.